Right, so first of all, good evening to all of you. My name is Eduardo. I am from Colombia. I am actually living in the Czech Republic 5 years ago, and I am working with coffee. So today I want to talk to you about the coffee processing technical challenges and limitations, but we will focus from the smallholder's perspective. It's going to be in English, so I hope you will understand everything, and if you don't, just tell me to repeat, I have no problem. And alright, so let's start. So about me. So I started my bachelor's in mechanical engineering, then I studied a master's in applied mechanics, then master's in process engineering, and I studied this second master's actually in the Facultad Strojní in ČVUT. Then I studied a little MBA just to try to get together some finance and management knowledge. And right now I am finishing my PhD in the Faculty of Tropical Agri-Sciences in ČVUT. I belong to these three research groups: food security research group, biogas research team, and also the post-harvest discipline of the National Coffee Research Center in Colombia. They treat all the matters involved with coffee production from the scientific point of view in Colombia. And I have been working in the industry also quite a long time, just for you to get to know a little background of myself. And we will be talking about these following topics. So, coffee process from the seed to the cup. It's important to know what is actually coffee, because a lot of people, they drink it during the morning or they have some dessert with coffee, but they don't actually know what is coffee. So even at some point I had the comparison, I had several different pictures, and I asked to some people what do you think is coffee? And there was a palm, there was a tree, there was a bush, there was, I don't know, some random long plant, and they thought it was palm, some others they didn't know at all. So we will do a little trip so you can see what's behind that cup of coffee that we have every single morning. Then we will be speaking about the post-harvest methods, because I am not working with the crop itself, I am mostly working in the post-harvest issues from the engineering point of view. Then we will speak about the step-by-step solutions in the post-harvest steps, mainly because this is what affects most the coffee growers. I will speak a little bit of what I do, the impact of the post-harvest processes and how to do it properly, and short take-home message. Alright, so if you have any questions, just let me know. So from the seed to the cup. Okay guys, so this is a coffee plant. Coffee plant is actually a small tree. That's what it is. It's not a palm, it's not a bush, it's a small tree. And this is how it looks, like the branch with the flowers. Yes, coffee has also flowers, and they're really beautiful. They are white and small. And this is the fruits. These are the fruits. The fruits, of course, they vary according to the variety and also the species that we are talking about. Most likely you have heard about Arabica and also Robusta or Canephora. And they change a little bit. But this is how it looks generally. Now, where we can find coffee? We can find coffee in these countries. So maybe you see something really funny, that all the coffee region, or the bean belt as it is called, is actually in the tropics. So you cannot find coffee in a country with seasons because it needs the tropical climate to be able to grow. The main coffee producer in the world right now is Brazil, then is followed by Vietnam, then is Colombia, Indonesia, and some other countries. But what I want to point out here is that you can see how massive Brazil is. They produce a lot. But then in the second place is Vietnam, that is a small country, Colombia, that is a small country. So this actually has a really big impact in the society itself, because it's more like a culture, it's a tradition that all the country is turning around coffee. Now, this is what I was telling you. So Brazil is the #1 producer in the world with 63.4 million sacks of 60 kgs, each one of them. So it's massive, as you can see. Then we have Vietnam, Colombia, third place, Indonesia, and Ethiopia. Now, the 75, so these countries, they account for the 75% of the whole world's production. But then you can also see something really interesting that we have Brazil, Colombia. There is also Vietnam, Indonesia, and Ethiopia, of course, but most of the coffee is actually sown and grown and produced in Latin America. Central America, South America accounts for around 70% of the whole production of coffee. You can see, for example, here is Honduras, we have Peru, we have also Mexico, Costa Rica has a lot of really good coffee as well. And now we will talk a little bit about the species themselves. So there are more than 100 different species of coffee in the wild, but only 3 of them are planted. Those are Liberica, Robusta, and Arabica. So those are different species. Now, I would like to make the example, it sounds like a little bit strange, but let's say that Liberica is a coyote, then Robusta is a dog, and then Arabica is a wolf. That doesn't mean that one is aggressive and the other one is, no, that's not the point. The point is that each one of these are divided in, afterwards they have like their own races, let's say like that. So there's not just coyote, but there are coyotes, like there's a Mexican coyote, I don't know, American coyote, Colombian coyote, I think is this one. Then dogs, you also have pug, you have German Shepherd and so on, and in wolves you also have different wolves. So what I want to show here is that the species, Liberica, Robusta, and Arabica, which we have them here, they are to the dogs and these things as they are like coyote, dog, and wolf. But inside the wolf, there are different breeds, as in the dogs, and in coffee, they are called varieties. So we have Arabica, it has varieties Castillo, there is Rosario, there is Costa Rica. Also, Robusta has Canephora, Kutumari, Uganda, and so on. Then you ask yourselves, okay, so which one do I choose if I have a plot? So you choose the variety also according to something similar as you choose a dog. Of course, some are more difficult to get, but for example, if you are living in a cottage in the wild, you are not going to take a pug. You would rather take a big dog that can protect yourself and so on. But if you live in a flat, you are not going to get a husky, right? You will get a small dog. So the same thing is with the coffee. So for example, some varieties, Castillo, Cafe Uno, and so on, they are resistant to some diseases that affect the coffee crop itself. So, but others, for example, Caturra has a really good taste, but it's not, it cannot fight the diseases. So coffee growers usually choose according to what they want, but in some countries it's forbidden to grow different varieties. For example, in Colombia, it's just Arabica is sown because it actually raises the quality of the coffee itself, and the quality is what is giving the final value to the coffee. Then we also have some random example that if we have a horse that for some reason falls in love with a donkey, they will have a mule, right? Or if a horse falls in love with a zebra, they will be the zebroids. Or if a donkey falls in love with a zebra, they will be the zebroid. What are all of these? So all of these are called hybrids. And you can see that also in coffee. So there are hybrids, for example, the Timor hybrid, the Jember hybrid, and the F1 hybrids. All of these hybrids are having also their own characteristics, their own resistance, and so on. And here we have Caturra. Caturra is a really worldwide known coffee mutation, but they call it actually variety. And it's a mutation from the Bourbon variety. And it's a really nice history because in Brazil, back in the maybe late 1800s, they were growing Bourbon variety. And some guy was right on the field and he was just looking around, and then he saw a really small tree. And that small tree was giving a lot of fruits, but just once a year, because Brazil, they have just one harvest season. So that small tree is the actual Caturra mutation, and it is, let's say, dwarf from the Bourbon variety. So the same as humans, you go to the metro and then you see some person with dwarfism, the same happened in this case. So they took this Caturra and they put it to Colombia because in Brazil there's, as I said, just one harvest season. So it gave a lot of coffee, but then it was like really exhausted. So they took it to Colombia, and in Colombia we have 2 main harvest seasons, and it was giving coffee like crazy. It was really good at the time, but then Caturra is not resistant to certain diseases. So right now the whole Colombian Federation is trying to replace the Caturra with disease-resistant varieties. Now, speaking about the species, Arabica and Robusta are the most known in the world, so Coffea arabica, Coffea robusta. And then you also hear that, for example, Ethiopia is where the coffee was found, but that's not completely true. Ethiopia is the origin place of Arabica, but Congo, the Congo Basin, is the origin place of Robusta. There are some difference between them. For example, the altitude where you can sow this coffee, the market share, you can see that the 70% of the market share is actually Arabica and 30% is Robusta. So if you really want to have a coffee that tastes good, that you can enjoy, you should most likely take some Arabica. And if you just want to wake up to get like a high dose of caffeine, you most likely would like a Robusta. But with this, that's like a different stage, because right now what people care about is mostly, not people, but like the people who sell coffee, they just care about getting the money. So they are actually blending both Robusta and Arabica, and they sell it under, for example, some Arabica majority, but it's actually not true, and it's diminishing the quality of the coffee itself. So you can see, for example, the Arabica has sweeter and softer taste, the Robusta has a stronger and harsh, and it doubles the amount of caffeine in this grain. Okay, now this is the map of what kind of species is sown in the coffee growing countries. So you can see that all Latin America is having, most of it, is having just Arabica. Brazil and Ecuador are the exceptions where they have a mixture between both. But you can see here, the Congo region, here, and also in the Guinea Gulf, they just sow Robusta, whereas in Ethiopia, Somalia, and in the sub-Saharan Zambia, Zimbabwe, they have Arabica. It's a different story with these countries in Asia where they do not have Arabica. So it's really interesting, because being Vietnam and Indonesia, like highly productive countries in coffee, they just produce Robusta and some mixture. But that means that the highest quality coffee, that is actually the Arabica one, is produced in Latin America, as I said to you before. Now, making like a small focus in the Colombian coffee culture, I wanted to show you this map where we have the trade winds in the intertropical convergence zone. These trade winds are those who are moving the rainy seasons in the tropics. So you can see that, for example, this is the July one, this is the January one, and it means that in these countries, you will have most likely probability of rain in those times. But then you see here Colombia and Venezuela, but mostly Colombia. And if we make a little zoom, so we have this image. So what does it mean? It means that in Colombia we have rain most of all the year. Of course, it's not like a monsoon, but there is rain all year through. So here in the southern part of Colombia, we have the main harvest at the beginning of the year. In the north part of Colombia, we have the main harvest at the second semester of the year. And in the middle part of Colombia, we have coffee all year round. Something like this. So main harvest first semester, main harvest second, and both semesters. So the coffee is actually, because it's raining, it's sunny, it's raining, it's sunny, so the coffee plant in the center, mostly, is receiving mixed signals. So it receives water, then no water, then sun, then no sun. So the plant is flowering, giving fruits, and then again, and again, and again. That means that in Colombia we have fresh coffee all year round. This is very important because in Colombia we have more or less 541,000 coffee growing families, from which the 96% are considered to be small coffee farmers. And they have an average size plot of 1.2 hectares. So they really need coffee. They need to be able to get money and to be able to survive under the weather circumstances. Now, I spoke to you about certain varieties and certain species but there are like a lot of varieties. It's almost like non-ending. And even they went, for example, to Ethiopia, and they found in the wild more than 1,000 wild different coffee varieties. But not all of them are, of course, planted and grown and sold. So these are, let's say, the most known and the most important in the market. You can see, for example, we have here the Bourbon one that I already explained to you, that was the one holding the mutation Caturra. And I think that this is even not updated, because the research centers in the countries, they constantly develop new varieties to fight diseases and to fight, for example, yield. They're having more yield or having less yield, taste, and other factors. Now, why they are developing new varieties and why they want to change and what they want to improve some of their already sown and grown varieties. So this is why. These are the main pests that affect the coffee in the world. So this is called the coffee rust. So basically it's a fungi that spreads through the leaves, and then the leaves fall down. And the leaves, of course, are needed for the plant to do the photosynthesis and to do the metabolic cycle. So basically it kills everything. And that is something really important, because if you remember, when I showed you the graph with the wolves and with the dogs, the Arabica species, it self-pollinizes. Meaning that in, for example, Latin America, all those plants that you can see are somehow like related to each other. Even though they are not having the same genetics, they are together related to each other. So what happens if this disease comes to Latin America? So all the coffee crops in all the countries is going to be threatened. That's why they're trying to develop new varieties, and they have succeeded to avoid this fungi, for example. Then we have the coffee berry border. It's a small bug. It's like a Coleoptera family. And they just eat. They go inside this place in the coffee fruit that is called actually the belly button of the coffee fruit. They go inside and they just eat the whole seed. And they lay eggs inside, and then they screw the whole process. And this guy is really complicated to manage, because there is no way how to stop him to get inside the grain. They have developed some techniques, but the only way how to actually fight it and change it is to do some transgenic variety of coffee. And they have been working actually on it, that as soon as the bug starts eating the meat of the grain, they modify genetically the grain. So some enzyme is put inside the material, so it actually degrades and like dissolves the whole digestive tract of this bug. But transgenics are not having like good fame. So especially with coffee, they want nothing to know with transgenics. So it's not possible to fight it right now. And then we have the CBD, which is the coffee berry disease. It basically just like empties the grain. This disease is just right now is just in Africa, but maybe eventually it will come to Asia or Latin America. So that's why they are going one step ahead and developing and delivering new varieties that are resistant mainly to this one and to this one. And yeah, so that's one of the things. And now I want to talk to you about really what's the coffee process like. So these are the seeds. So we will start from the seed. And the seeds are usually dried maximum at 38 degrees Celsius, because if we exceed this temperature, then the embryo is going to die. So if the embryo dies, of course, the plant cannot afterwards grow or be born. Then we have to lower the moisture content to 10 to 12%, and the initial moisture content is more or less 53 when we are working with the wet method to produce the seed. Now you can see here the embryo, and this is the dry seed. So this is the endosperm. The endocarp is also called the parchment. Is some sort of skin that covers the seed just to protect it. Then when we have the berry, the red berry, this is the distribution that it has. It has 44% of pulp, 20% of mucilage, 5% the parchment, and 31% the seed. Now this mucilage is some sort of film, it's like really slimy film that covers the seed. And this one is the responsible, that mucilage is the responsible for the fermentation process in the coffee. When you are producing it, when you take it out from the tree, the berry, it starts the fermentation process. That is actually not a fermentation, but it's a degradation of that parchment. And that one is really important because it can give good or bad taste to the coffee in the end. So there are two main or major ways how to produce coffee. We will see them, but just so we can speak about the mucilage. There is a natural or dry method and the wet method. So in the dry method, we let all this berry to dry alone by itself. It's just like you take an apple to your home and then you just leave it there and it will dry. That's the same. But in the wet method, we remove this flesh first and then we ferment, we wash. What happens is that if we leave it like this mucilage is going to fermentate anaerobically because there is no presence of oxygen. But if we remove the flesh, then it will fermentate or degrade aerobically because there is presence of oxygen, and that can change the taste in the coffee. So right now there is a lot of research going on with the honey coffees, with slow fermentation, fast fermentation, and so on. And this is actually giving a really wide scope and broad options of taste in coffee. Now, these are once the seed is planted and it starts to grow. These are the seedlings. It's also called phosphoro because it's looking like a match. When you want to light up your cigarette or something, it's looking like that. And after the first year, more or less, there is the first flowering. So this is how the coffee tree looks like with the buttons of flowers. So it's actually pretty nice, especially when you have like a whole mountain sown in coffee. The whole mountain is white. It's really beautiful. Afterwards, the berry starts to grow. So there is like the green berry, there starts the ripening, and then this is the ripe berry. Same situation as a normal fruit. You have the green apple, and then it starts to ripe until it's red. Now, what happens when the berry is ready to be picked up? So there are mainly two harvesting processes. One is happening usually in the country of origin, and the second one is usually done in the country that is actually buying that coffee. So the first one is, as I said, we can do all the process through the wet, dry method or natural method before exporting. So pulping, fermenting, washing, blah blah blah, and then it's shipped, for example, to Europe as a green coffee or like as an almond. Then it arrives to Europe, for instance, and here in Europe happens the roasting and the grinding prior to consumption. So these are the two main post-harvest processes, but we will focus on this stage number one because actually there's nothing going on in this one, just roasting the grain however you want to drink your coffee and grinding it to decide that you want to drink your coffee. That's it. But this one is having more magic. So the wet method is really common in Central and South America, except Brazil. In Brazil, they are letting it dry on the branch. We will see it, and also in East Africa. The dry method or natural method is very common in Asia, Brazil, and West Africa. So what are the stages? So the wet method, we pulp, that means we remove that flesh from the berry, then we fermentate or degrade the mucilage and we wash, then we dry, then we peel that parchment or that skin that covers the seed, and then we have the green beans, the seed itself without any kind of protection. And the dry method or natural method, we take the berry and we let it dry itself, and then we remove that mixture of the parchment with the dry flesh, and we have the green beans. These are the byproducts, so we have pulp, we have mucilage and wastewater, we have husk, and we also have the parchment and the silver skin. So these byproducts right now, they are like a really big problem, especially in the wet processing countries, because it generates a lot, as you can see. And especially this mucilage and the wastewater, because that's why it's called the wet method. You need to put water to wash the coffee, and that whole amount of water is going to the rivers and to the water sources, and that's of course not desirable. Now, the wet method, so we handpick the berries, we pulp them, so we remove that red flesh, So this is how they look. They are right now covered in that mucilage, in that slimy film. Then we degrade it, we ferment it. It's normally happening around 18 to 24 hours, this fermentation process. Some countries do it more. For example, in Ethiopia, they can do it until 32, 48, but it depends on the taste that you want to take in the end. Then it's washed. You have to remove all of those residues, washed, dry, and peeling. So this is how the coffee is actually exported, also known as green coffee. But the natural or the dry method, so in some countries, for example in Vietnam, they hand pick and then they take these berries and they just let them dry, just like that. But in Brazil, they let the berries dry in the branch, and then with these machines, they just go like shaking the whole tree and they collect. The problem is, as you can see in this mass, that there are dry, green, ripe leaves, branches, so this is diminishing the quality. And this is how the seed looks like when it's already dry. So then they just remove the flesh that is already dry with the parchment, which is already included, and then we have the green coffee. In the end, we have the same product through different methods. Now, speaking of, this is the map of Colombia. Now I want you to know, or I want to speak right now about the challenges of doing those processes that we already mentioned. So the first issue is the harvesting. We will start again in order. So the first problem that the coffee grower faces is the harvesting. Why? Because at least in Colombia, these are the coffee producing departments of Colombia, and this is the topographical map of Colombia. So you can see that all the coffee from Colombia is produced in the mountain regions. So you see heights of 5,000, 4,000, 3,000, really high. Coffee, in such case, is produced between 800 to 1,800 meters above sea level. But still, this is how it generally looks. So you have to go and take coffee. So what do you see? That you cannot put a machine through the mountain that is going to shake the whole tree. And the second problem is that in these countries they're doing selective harvest. So it's also an issue. So they have to take, some people have to go to the field, hand pick, and right now with all the, let's say the field work, nobody wants to do it, so there is like a shortage in people wanting to work doing coffee picking. Now, not just about Colombia, but also Ethiopia. So these are the coffee producing regions, and then if you take a look at their topographical map, there is the same problem. It's different than Brazil. Of course, Brazil also has a lot of coffee in the mountain regions, but you can see this is a typical coffee plantation in Brazil. So it's flat, they can put their machines, they can shake their trees, and well, that also, because they're using the natural method, that also eases the coffee production in Brazil. Also, we have to keep in mind that some countries, they do not use the wet method, not because they don't want, but because they don't have the water to do it. So in some countries, that's why you see, for example, Colombia, Latin America, Central America, Ethiopia, they have better access to water than, for example, Brazil. It's a huge country producing 68 millions of sacks. So how do you wash all of that? So that's a problem. So that's why they rather use the dry method, and they use these machines. So they just shake the whole tree. But what we can see, as I said before, there are detachment of unwanted beans, the unripe, the leaves, overripe, and so on. So we have developed some technologies to remove just the ripe beans, as you can see in this video. It's really challenging because, for example, then the beans are flying all around, they have to go to the ground. I will maybe play it again. They're flying all around, going to the ground, so it's somehow extra work, but at the same time you are saving money in hiring somebody or hiring a lot of people to come and pick up the coffee in your farm. There's still a lot of work to do. This is also used, these fingers are like going through the branches, and well, first of all, they are like kinda ineffective, but also they do a lot of damage to the tree. So they can remove leaves, and remember that the leaves are like the gasoline of the tree. It is the one that is proportioning energy to the tree so it can work. So if you are taking down the leaves, so that's also non-desirable. And also loss of beans. But they are still working in getting this problem solved. Now, pulping solutions. So when we are pulping the coffee, the main issue is to separate the green beans that we selected, because, for example, this mass of coffee that you see here was hand-picked. But you can see still some semi-ripe beans, some green beans, and so on. So what we have seen, for example, in Colombia, is that even though we are using the wet method, we do not need to add water in this stage. Back in the time, they were putting water, but now it's not needed, so it was a reduction in the water consumption. And just that action is reducing the water contamination, the pollution, by 74%. The coffee quality is the same, the power is the same, and the coffee pulp is richest. Why do I say that it's richest? Because it's not diluted in the water, and further it can be used, for example, as a biofertilizer, or it can be used as, we can produce ethanol with it, and so on. So this is a depulping machine. That's how the process is done. So the coffee goes up through this screw, then it's fed to this pulping machine. The coffee is squeezed, and then it's separating the seeds. Then it's classified according to its size through this rolling drum. And there it is, the seeds ready to be fermented. Now, in the end, it comes like this, and here in the bottom you saw a bucket maybe. There are the green berries, the non-desirable coffees, and yeah, so this is helping a lot, especially the small coffee grower, because it's something that he's going to use all year, and he can have it in like small space. Now, in the fermenting solutions are very important, because back in the time they didn't know how or when it was ready. So they put the mass of coffee, and they waited for some time, and then after they took a sample and they just washed a little bit, and they were like doing it with their hands, and then they heard and they said it's ready, because there was like some marble sound between them. But it could be ready or it could be not ready. Also, when they had the whole mass, they used to take like the stick of a broom, they put it inside, and then they left it for a while, they removed, and if the whole coffee crumbled again, it's not ready. But if the whole was still there, like in the golf court, it was ready. But these methods are not that exact, so this one was developed by the research team, and it's really simple. It's like 3D printed element that you fill with coffee. When you are going to ferment, then you wait for a while, and when the coffee, remember that it's filled, when the coffee goes from this top to this line, it means that it's ready. Doesn't matter what kind of coffee, it is ready. So it's really handy and really useful tool, especially, as I said, for small coffee growers, that you cannot come to them and say, program this and put this signal here. No, they need easy things, cheap things that they can use on their daily basis. So this is one of the technologies that is actually helping them nowadays. And also, there are other methods that are like a little bit less orthodox. For example, this is the demucilaginator. It's a machine that when you take the coffee right after pulping, you just put it inside, and then it will start turning, and by centrifugal forces, it will just like throw the mucilage away. So it's making it faster, but you need energy, you need money to buy this machine. And also there are some enzymes that accelerate the degradation process. And with the enzymes, the whole fermentation process that naturally takes around 18 hours, it can be done in 1 hour. But also acquiring these enzymes is a bit complicated, and well, the coffee growers are usually having large amounts of coffee, so you will need a lot of enzymes, which is not ideal for them. However, some of them use them, especially this demucilaginator, because it actually eases a lot in the process. Here you have another shot of the berry with all the elements that conforms it. And this is the main issue right now when we are using wet method, washing. So back in the time, in the 90s, the water consumption when you were producing coffee through the wet method was 40 liters of water to produce 1 kg of dry coffee. So just imagine, 40 liters per kg. That's insane, that's a lot. But in Colombia, for instance, we are rich in water. We have a lot of water. So taking 40 liters per kg, it doesn't seem a problem. But the problem is actually that we are releasing 40 liters per kg of polluted water to the rivers, right? So that's the main issue. Of course, the water consumption shouldn't be like that. We should save water in every single stage. But more than the consumption was the discharge afterwards. So a lot of technologies also have been developed to reduce this water consumption. So you can see the timeline, 1993, 3 liters per kg, 1995, 1 liter per kg, 2012, 0.4 to 0.5 liters per kg, and the latest technology developed was the EcoMill that is actually consuming 0.5 to 0.6 liters per kg. This is still something, but you can see that there was like a notable reduction of 39.5 liters of water, and also in the power that the engine needs, the motor needs, 0.5 watts per hour is almost the same as a blending machine that you have home to produce, like do some juice or whatever. And this amount of water is actually reasonable from consumption, and it's also reasonable for after wastewater treatment in the green filters with vetiver grass, our biogas production, so it's more manageable, this flow, than 40 liters per kg. Now, when we speak about these machines, yeah, they sound really nice, but like actually how much or how many energy do you need? So back in the time, the Becquerel soup needed 64 solar panels, EcoMill 16, but the last one, the EcoMill LH300, needs just 4. And right now there is a really big movement towards giving or applying solar or photovoltaic panels in the coffee growers' farms. So with 4 of them, they can perfectly wash, and also these 4 will be good for the pulping, washing, and also even for drying. So why are we washing? We are washing to remove that mucilage that was already degraded. That is called honey water. So the honey water is here. It can be recirculated, and this is how it looks like. Yeah. So you can see that this is the fermented coffee. This one is here clean already, and this is the honey water. So just imagine 40 liters per kg of this going to the rivers. So, and this has a really big potential to work as biofertilizer supplement. So you take the pulp that I already showed you before. We take the pulp, we put it in some bed to dry, and then we wash it with this water. We wash it, we wash it, we wash it, and that pulp will start holding the solids of that honey water, and it will increase its biofertilizing properties. It will raise the nitrogen, it will raise the phosphorus, and so on. So this is one of the techniques that is being done. And now I will speak to you a little bit about coffee drying, which is actually what I'm mostly researching on. So the main issue, for instance, in Colombia is that the harvest peaks are coincident with the rainy seasons. So what does it mean? That there's less direct radiation, which will lead to sun drying problems. So the coffee growers, they have to sell it wet for less price. They have to pay somebody else to dry it in some machine. They're wasting money, or they just risk to spoil the coffee because the wet coffee can generate microorganisms, mycotoxins. There is the ochratoxin, which is a cancerogenous element, and so they have to do something with that. But in all of these 3 cases, they are having low profitability. They're losing money if they sell it wet, they're losing money if they pay somebody else to dry it, and they're losing money if they spoil the product. Now, as I said to you, the 96% of the Colombian coffee growers are considered to be small, so they use as a primary source of drying solar energy. The problem is that the solar energy is a stochastic process. It means that it cannot be predicted because it relies on a lot of conditions: the rain, the sun radiation, the relative humidity, so you cannot actually predict that. And it's a passive drying. It takes from 7 to 14 days. It needs a lot of area. In 1 square meter with a 2 centimeters tall layer, you can produce 12.5 kilos of dry coffee. So it's like you need a lot of area, right? Then it's dependent on the weather, but it has a cheap construction and operation. It's environmentally friendly. The clients usually prefer this kind of dried coffee, and it longer preserves the in-storage grain quality. Why they like this coffee more? Because there is a direct relationship between the direct sunlight and the quality of the seed, because when it happens, something called seed hardening occurs, and this actually holds the taste, the flavors, more than the mechanically dried one. On the other hand, the mechanical dryer, it's active dryer because it's forced convection, so the air is going actually forced through the coffee layer. You need low areas. For example, this small equipment is like 1.5 meters, and it can produce up to 7.5, so it's like 100 kgs of dry coffee in 21 hours. But, well, and this is a deterministic process. We can predict it actually, because if we take the air to a certain stage, with the psychrometric conditions, we know how long will the coffee take to dry. On the other hand, it's not environmentally friendly, and it can kill the endosperm of the coffee, not the embryo, but the endosperm, meaning the seed, so it will lead to a rapid degeneration of the coffee seed itself, and it will damage the structure, and it will release some fatty acids, some lipids that will damage the taste of the coffee. Why it's not environmentally friendly? Because, well, right now they're using a lot of biomass. It's okay because somehow it's carbon neutral fuel, but some of them are also using gas, normal gas. Back in the time, even they used, for example, some charcoal to heat some air through heat exchangers, but it's not recommended. So right now there is like a really big boom on hybrid solar dryers, which mean actually mixing both of these technologies. So you will have active drying, low area requirement because there's a high drying rate. It's not depending on the climate 100%. It's cheap to construct, environmentally friendly, and it can be actually applied to all technologies. So this is actually not this one, I will show you in a second, but this is the topic where I'm working on my dissertation thesis. And I just came on Thursday from Colombia, and we built the hybrid solar dryer, and it's working really nice. I will show you in a second. And why drying coffee is that difficult? Well, because of the internal structure of the coffee itself. So you can see this image. We have polyhedral cells. We have also rectangular cells. We have some discontinuities inside the coffee, and there are some furrows inside the grain. So this is actually not letting the water escape from the inner side of the grain, and these places can become hosts for, as I stated before, microorganism or bacteria. And it has 53% of moisture content when using the wet method, so it's really high. And you can see the water concentration is actually really inside the grain, somewhere here, where they have the typical furrows. So we should really take care. This is the most important step in the post-harvesting processes. So that's why the coffee growers, like, they suffer the most with the drying. Now, this is the pulp, the used or spent pulp. So they put them in this kind of beds, they let them dry, and then they wash it with the previous honey water that I told you. So this honey water is not just once. It goes to a tank, then they do it again, to a tank, then they do it again, and like this it will hold these materials and the elements that can improve the biofertilizing properties of this pulp, and it also can be used to produce biogas. So there is a really rich organic load in the pulp. Now, the byproducts of the coffee production, I want to speak a little bit about them. So the pulp can be used as a fertilizer or to produce biogas. There are like 2 million tons produced just in Colombia of pulp. Now the mucilage is used to enrich the pulp, also for biogas, and just 1 kg of coffee produces 31 milliliters of this mucilage water. Then when we take the coffee, the dry coffee, and we hull it, we will have the parchment, also called the husk. Thank you. Also called the husk. And it is usually used to produce thermal energy as a biomass to burn in the silos and to dry the coffee. This energy can be used to dry or to produce electric energy, but right now there is a shortage on this material because all the companies, they want it to use in their boilers. So this is an issue. And also, these are the trunks of the coffee. So now you see the Colombian National Federation of Coffee, they suggest the coffee grower to renew their crop one time, or 1/5 of the crop, one time per year. So if you have 5 hectares, one of them you will renew it. It means that you can take off the tree and plant a new one, or you can cut it at 60 centimeters and a new tree will come. Why? Because it will maintain the coffee growing region young. It's the same as with a person. If we have an old person, well, it's going to be more difficult for that old person to run and to do energetic labors. So they try to keep it young. And that keeping it young is actually creating a lot of biomass. So you see, just with the renovation by cutting the tree, 1.5 million tons of that material is created. The energetic or the calorific value of 1 kg of that material is 17,000 kilojoules. If we transfer this, we have 25,500,000,000,000 kilojoules just stored in this mass. That is 7,083 gigawatts per hour. And this value is the 10% of the energy consumption in Colombia in 2021. And this energy is stored in these trunks and it's left in the field. Nobody's doing nothing with it. They just chop the tree, they do some mountain with that. They use more or less the 10% for cooking in their homes and to use it for different labors, but they just give it away to other people. So we wanted to use this as a source for thermal energy and to burn it. Now, that material can be chipped, small chips, to improve because the trunk is really dense, so when you're trying to burn it, due to the lack of oxygen, it might burn really low. You need it really, really dry. So it can be chipped. For instance, this is a gasifier, so we use the chips to produce hydrogen, methane, and other gases, and the pulp, it can be used to produce ethanol. Now, what I do with all this story. So, in the harvesting processes, I am trying with my research team to find out or to design some machine that actually do a selective harvest with air. So here you can see some vortexes and some experiments, but if you have ever seen, for example, this Tacoma Bridge video, it's like some bridge that is like waving and suddenly falls, is because there was the natural frequency of that specific structure was achieved. So we calculated the natural frequency of the grain in all the stages, ripe, semi-ripe, and unripe. And then what we do is that we excitate the coffee bean at those specific frequencies, so we know that it actually will fail, it will collapse. And then with the design of the nozzle, we can throw some high pressure air at that specific frequency, and then you can see that, for example, that shot is not going to take down the green, but that same shot is actually going to take down the red, because we reached that natural frequency of the red bean. Of course, there's a lot of work to be done. It's just, let's say, the previous steps to start developing it properly, but we want to target this stage. Also, this is the hybrid solar dryer that I just designed. I just came back from Colombia. We were testing it. So you can see it has a photovoltaic system which actually holds or saves energy in this battery. It has a charge controller that powers the fan and also saves energy at the same time, so it can work during the night. So just remember that solar drying has no drying during the night, of course. So those are 12 extra hours that now they can be used. And also, by the use of these trunks, we are closing somehow that gap. So during the night, you put the trunk, you have solar system to power your dryer, and you have 12 extra hours. So this is somehow the mechanical drying part, and also during the day, if you have just a little bit of coffee, if there is a really beautiful day, you don't need to turn it on, you just dry normally as this one here. Okay. Also, I am really involved in the CFD simulation, computational fluid dynamics, to improve the drying process. And also, lately I have been working a lot with roasting, mainly with the pea berry roasting. So you can see this is a pea berry. A pea berry is a natural defect of the varieties. So one seed or one berry actually holds two seeds, one facing each other. But for some reason, there's some genetic condition that one berry will give just one seed. And that seed is not like one facing each other, but it's like a round one. It's this one here. And they say, or there is the theory, that the pea berries are having better cup. And it can be because of their shape, so that's what I'm trying to prove. But anyway, I just wanted you to know this. 1 pound of pea berry, for example, in Colombia, in Costa Rica, in Vietnam, they are considered to be like waste. They leave it for internal consumption. But 1 pound of pea berry in Hawaii, it can be 50 USD. So it actually has a lot of value. So that's what we want to show. And now the impact about all this speech is basically that the coffee bean is the second most traded commodity in the world. So after petrol, after oil, coffee is the most traded commodity element in the world. So then you can think, okay, it's mostly produced by who? It's mostly produced by the southern part of the world, you know, like tropics. But the marketing and processing, the second stage, like I told you, roasting and grinding, is largely dominated by northern countries, US, Europe, Japan. So there is like 150 million years, so 9 million tons of coffee each year moving around the world. We just see it in the supermarket by half kilo, but it's a massive industry. Now, regarding this, 125 million farmers are actually involved in coffee producing, and they make like the direct living from it. So 80% of, not only in Colombia, but 80% of the farmers in all the world are owning less than 10 hectares. So they are also small, like mid small. And they are facing all of these issues with the weather, with the technology. So we could actually forget for 1 second about the coffee that we're drinking in the morning and think about them, how to help them through this, what I show you through these processes. Now, Latin America accounts for the 70% of the global production. Of course, we have to thank Brazil for being such a massive country producing coffee. But anyway, you can see Latin America is mostly developing, all these countries are developing countries. Then Asia, also developing countries, and Africa, also developing countries. So we can actually make an impact and make a change in the chain. Then, after water, coffee is the second most consumed beverage. So it has also a lot of impact, and the global demand for organic coffee is doubling. So right now there is more demand for organic coffee, and the organic coffee production is actually, let's say, more complicated, because they cannot, if you want the organic stamp, you cannot use you cannot use agrochemical, you cannot use normal fertilizer, you have to do everything bio fertilizers, and the water sources and so on. So how to help this target is by going to the small growers, to those who actually need the technologies to be able to produce organic coffee and change it. Now, just some take-home message to finish the presentation is that the coffee production is like a huge thing in the world. It is not a matter of just America, just Asia, or just Africa, but everybody is drinking coffee. Everybody is enjoying a cup of coffee in the morning, for studying, for every single thing. So it's a massive world, and I believe that everybody can help somehow to this process. There are a lot of things to improve. That's why we're using research. Yeah, there is a lot of also like hearsay in coffee, that if you plant with the moon and you go out and then you smell, and then this is okay, but no, we need to do it through research to be able actually to go and help the small growers. Again, the small growers are the engine of this process, but that same reason it's a challenge, because we have to deliver solutions that they can actually get, that they can actually put to use, because it's nonsense to design a massive machine needing a lot of energy and a lot of control and give it to the small coffee grower in Ethiopia or in Uganda. Use it. He's not going to use it. So we need to somehow merge research and this challenge to deliver things that they can actually use. And now we are, of course, trying to use the sustainable technologies. And keep in mind, the tropics, they have sun, they have water, blah, blah, blah. So we can use sustainable processes that are actually according to the SDGs of the United Nations. And as the last message that I want you to know is like, be just and be fair with not only with coffee, but most of these products like banana and all these elements coming from the tropics and developing countries, because sometimes we do not realize what's behind the process itself. Thank you very much.